This is question 19 in chapter 21. It has 3-point charges on an x-axis. They give us the charge for 3 and the position for 2. The question is, where would we place Q3 on the x-axis in order to get a net charge on Q1 to be 7 newtons in the negative x direction? Now, we have the charge of Q3 along with Q2 and Q1. Let's deal with this force of net Q1. What does it mean? Well, we know that any net force on Q1 is going to be affected by the point charges that are surrounding it. So that means that it's going to be equal to the force of Q2 acting on Q1, and it's going to be affected by the force of Q3 acting on Q1. When looking at this, we know how to find Q2 on 1. We're going to use Coulomb's law. So the force of Q2 on 1 is equal to K Q1 Q2 over R squared. This R is the distance between Q1 and Q2. We can go ahead and plug in all these values. K is a constant. It's 8.899 times 10 to the 9th. And its units are newtons meters squared per coulomb squared. So it's going to equal K times Q1, which is 3 microcoulombs. We need to change that to coulombs to be in SI units. So that's times 10 to the negative 6 times 5 and negative 5 times 10 to the negative 6 over the distance between the two. This is quite easy to figure out because Q1 is at the origin. So the distance between 0 and 0.2 meters is 0.2 meters. When you get out your handy-dandy calculator, you're going to find that F of Q2 on Q1 is about 3.37 newtons. All right. Now we have F of 2 on 1, and it was given to us what F of 1 is. So intuition tells us that 7 newtons is going to equal 3.37 newtons plus F of 3 on 1. There's a trick to adding the forces up. You need to figure out which direction they're going to be in. Like we did in previous problems, the magnitudes of forces are always positive, but in order to symbolize which direction you want them to be going in, you should put positive and negative sides in front of them. This is only if they're going in completely opposite directions. We'll get into angles between them in later problems. But for right now, since it's on the x-axis and there's 180 degrees difference, we can just add positive and negative sides in there. So the question tells us that they want the 7 newtons to be going in the negative x direction. And that makes sense. So what are we going to do with this 3.37 newtons? Which direction should it be going in? Since Q1 is positive and Q2 is negative, we know that their forces are going to attract. So we know that the force of Q2 on Q1 is pulling Q1 towards Q2. So it's going in the positive direction. Now we can solve for F of Q3 on Q1. By just bringing it over to the other side of the equal sign, we can get F of Q3 on Q1 is going to equal a negative 10.37 newtons. Again, this negative sign is just telling us which direction it's going in. So now we can put into the picture that this is going to be F3 on 1. All right. Now we know where we can put our Q3. We know that in order for Q3 to be pulling on Q1 to get the net force to be a negative 7n, it's going to be going in the negative x direction. Now, you have some leeway in choosing which, if these signs weren't given to you, generally you would have a decision to make on what charge you would want to give Q3, and that would determine where on either side of Q1 you would put it. But in this problem, we are given that it's a negative charge. We know that Q1 is positive and Q3 is negative, and since opposite signs attract, we know that Q3 is going to be somewhere to the left of Q1. But we still don't have the exact position of Q3. And that's where this calculation is going to come in handy, because we can use Coulomb's law again and figure that out. So we know that f of 3 on 1 is going to be equal to k. The two charges that are being involved are 3 and 1, so we're going to do Q1 and Q3, divided by the distance between 1 and 3 squared. The distance between 1 and 3 is what this question is asking for. We have Q3 on 1, we have Q1, Q3, and we have this constant. So we can do the distance squared is equal to f3 on 1 divided by k. We can multiply this to the other side, so r13 squared of f of 3 on 1 is equal to k q1 q3. And then we can do r13 squared equal to k of q1 q3 divided by the force of q3 on q1. We can take away that square and make this square root, and this will give us our r3. In your calculations, you should get something around 1.144 meters. Now, the distance between Q1 and Q3 should be 0.144 meters. Thankfully, Q1 again is at the origin, so all you have to do is take the difference of the two. 0 minus 0.144 meters is equal to negative 0.144 meters. Therefore, Q3 is at negative 0.144. If Q1 was at any other point, say 1, you wouldn't get the answer so easily.